Okay, let us look at the event cash flows or annuities. Um, an event cash flow or an annuity occurs when you receive or pay an equal amount every year for a certain period of time. So what is critical here is that the amount that you receive or pay is same each year, and also for a certain period. So we are saying the period is known period, from start to end. We call it an annuity. That is an annuity. So when we are to find the present value of an annuity, this is what we do. Present value of an annuity is equal to the annual cash flow multiplied by the annuity factor. So we need now to understand what is an annuity factor. An annuity factor is a cumulative total of discount factors from year one. So what is it that we are saying? If we are taking annuity factor, for example here, annuity factor year 5, it means that all discount factors from year 1 to year 5, discount factors year 1 to year 5. This is what we are saying. But however, we have different ways of us coming up with this annuity factor. Let us look at how to come up with the annuity factor. We have 3 ways of us coming up with the annuity factor, and the answer is 1. So number 1, we can calculate the annuity factor direct calculation of the annuity factor. That is number 1. Let us look at how we can calculate the annuity factor directly. I'm going to assume that my discount factor here, I'm going to give an example. Discount factor is 10%, for example. So we are going to move with the 10%, and we see how to come up with the annuity factor. So we can calculate that annuity factor. I'm going to look at probably annuity factor year 5. We want year 5, and the discount factor is 10%. Year 5 at 10% discount factor. How are we going to do that? So let us look at the formula here. So formula for us to calculate the annuity factor is equal to, let me just do this, equals open bracket 1 minus open bracket 1 plus r. Your r is the discount factor there, plus r to the power negative n, and then double close divided by your rate. So rate is your discount factor. So in this case, we are going to have r 10% to the power minus n. N means number of years, so our annuity factor is for year 5. N is going to be 5, and then divided by 10% again. So let us calculate this annuity factor. Equals open bracket 1 minus open bracket 1 plus r, 1 plus 10%. It gives us 10%, 1.1 to the power minus 5, double close, divided by 0.1. So my annuity factor for year 5 at 10% is 3.7908. So that is our annuity factor. This is way number 1. Assuming that, an example here, assuming that I was going to receive 2,000 per year, right? 2,000 per year from year 1 to year 5. What is the present value of 2,000 annuity from year 1 to year 5. So if I want to find the present value of 2000 that I'm going to receive every year from year 1 up to year 5, discount rate is 10%. I'm going to assume that my discount rate is 10%. So PV, I'm going to have my format here. I'm going to have this format where I'm going to have my year cash flow, and annuity. Then I have my present value, which is PV here. So I'm going to have a box here. All right. So my cash flow is 2000. Year is year. I'm going to indicate that it's year 1 to year 5. And then my cash flow every year is 2000. My annuity is equal open bracket 1 minus open bracket 1.1 to the power minus 5 close divided by the rate. So my annuity factor is there. So the present value is 2000 multiplied by this annuity factor. So in other words, we can lay our cash flows from year 1 up to year 5, 2000, and we discount at 10%. The answer is going to be 7,581.57. That is how we find the present value of an annuity. So let us look at a situation whereby you are not comfortable to come up with an annuity using this way. You can actually lay your discount factors from year 1 up to year 5. I'm going to have my years here. Year 1, since I want to start from 1, 2, 3, 4, 5. And discount factor, I just need to put my discount factors. Discount factor 10%. So for me to discount at 10%, I'm going to have let me try to make these ones appear. All right, discount factor 10% is equal to 1.1 to the power minus year. Right here I'm in year 1, so to the power minus 1. I drag up to year 5. So if I'm able to do this, it means that my annuity factor, the annuity factor that I have here, if I can come and highlight this point, if I add all the discount factors from year 1 to year 5, I still get the 3.7908. That's what I still get here. So if you can check here and there, this is the same. So if you are not comfortable calculating your annuity direct, you can also make use of this table here. Right, I'll explain the advantages of using point number 2 over point number 1 as we proceed. That is method number 2. And then finally, if you want to come up with an annuity, another way is still to make use of the annuity table. So let us look at 10%, 5 years, all right, year 5, using the annuity table. So let us scroll down. Right here is the formula for you calculating the annuity factor. You can see the formula here. But now I want to calculate the present value of 2000 receivable from year 1 to year 5. So I need year 1 to year 5. So from there I need to go to period 5, where period 5 meets 10%. So period 5 and 10% here is 3.791. This is to 3 decimal place, and which is same as this one that we have here. Okay, so these are the 3 ways of us coming up with an annuity factor. So now let us look at the 3 types of annuities that we have. we have three types of annuities, right? Number one, we have what we call a normal annuity. Normal annuity. Right. What happens when we have a normal annuity? How do we identify a normal annuity? Is when cash flows start from year one. So any cash flow that starts from year one, we are going to have that is a normal annuity. How do we find the present value of a normal annuity? PV is equal to cash flow, like what we've done, cash flow times the annuity times annuity factor. This is what we do when we have a normal annuity. Let's quickly have an example of what is PV, what is the present value of 7,000, right, receivable from year one to year 8. Assume 12% to be the discount factor. 12% as the discount factor here. Discount factor. I have 12% as my discount factor. I'm going to have year, okay, cash flow, annuity, and PV, the present value. So how you come up with your annuity factor doesn't matter, but what is critical to understand here is that this is a normal annuity because our cash flow is starting from year one. So if a cash flow is starting from year one, we call it a normal annuity. All right, I'm going to indicate that my cash flows are year 1 to year 8 here. Okay, year 1 to 8. All right, let me write. Year 1 to 8, cash flow is 7,000 per year. All right, and my annuity factor equals open bracket 1 minus open bracket 1.12, because my discount factor is 12%. 1 plus 12% there to the power minus final year is year 8. Close divided by 0.12. Right, I have this as the present value. I multiply this and my annuity there. This is the present value of 7,000 receivable every year for years 1 to 8. That is the present value of a normal annuity here, which is fine. And then another type of an annuity which is not a normal annuity, we are going to look at an advanced annuity. Number 2, advanced annuity. Advanced annuity here. Right, what is an advanced annuity? This is when your cash flow is starting from year 0. Here we have cash flow starting from year 1. We call it normal. If a cash flow is starting from year 0, we call it an advanced annuity. So like what I have explained earlier on, to say that the annuity factor is a cumulative addition of discount factors from year 1. So what does that mean? It means that when we are calculating an annuity factor for year 0, the discount factors do not include the discount factor for year 0. And we know that the discount factor for year 0 is always 1. So what does that mean? It means that from the annuity factor that we have, we need to add 1. All right, so present value PV of an advanced annuity is equal to cash flow multiplied by, right, annuity factor plus 1. So the annuity factor, you need to add the discount factor for year 0, which is always 1. Let us have an example. Let's have an example. I'm just going to take this example here and we move with this one. I'm going to change the years. Let's have this one as an example. Right, what is the present value of 7,000 receivable from year 0 probably to year 7? Right, these are 8 years starting from year 0. Assume discount factor is 12%. So what is the present value? Our present value, we are going to find our present value this way. I'm going to copy this table again and change a few things here. Right, I'm going to have this one. I'm going to change year 0 to 8. It's now year 0 to 7, not year 1 to 8. 7,000. I'm going to change my annuity factor. So if I'm to find the present value year 0 to year 8, I'm going to have my annuity factor normal year 7, and then I add 1. I would like to do that here, because 1 minus 1.1 to the 1.12 to the power minus 7, because final year of receiving money is what we raise to negative. Okay, close divided by 0.12. Right, I have this as the annuity factor for year 7, but in this annuity factor we haven't included annuity factor or discount factor for year 0. What is it that I'm going to do? I take this and I add 1. Right, so my annuity factor is 5.5638. When I multiply, I get this one. This is how we calculate the annuity factor for the present value of a cash flow that we receive from year 0 to year 7. I can also make this presentation here 0, 1, 2, 3, 4, 5, 6, 7. I have my 7 years here, right, from year 0. Right, if I am to put my discount factor, right, I'm going to discount at 12% equals 1.12 to the power negative 0. This should return 1. That's the one that I've added to this, and I drag up to year 7. Right, if I am to compare that here, if I sum all my discount factors from year 0 to year 7, I have the same discount, the annuity factor, is the one that I've calculated here. It is the same. Alright, well, if I want to discount my cash flows using this layout, I can put cash flow. Right, we can still get the same PV, but this is going to take you much time. If I can have my 7,000 there, right, this 7,000 throughout, and I multiply to get PVs. PVs is equal to discount factor times the cash flow, right, I have up to year 7, right, and then I should have my final PV here when I add all these cash flows from year 0, all these PVs up to year 7. I should still get the same answer as the one that I have here. Same answer to the last decimal. So this is how we calculate an advanced annuity. Let us look at number 3, which is a delayed annuity. So I'm just copying that to save time. All right, so now we have a delayed annuity, which is the last one. Delayed annuity. This is when a cash flow starts when cash flow starts from a year, from any year All right, any, that is going to be correct, any year after year 1. So anything that does not start in year 1 but later after year 1, we call it a delayed annuity. An example could be if a cash flow e.g. starts in year 2 or year 3 going forward, right? Anything that starts from year 2 going forward, we call it a delayed annuity. So the present value of a delayed annuity is equal to cash flow multiplied by adjusted annuity factor. So we need to adjust the annuity factor, adjusted annuity factor. So from the definition of an annuity factor, automatically when you calculate the annuity factor, it is going to add year 1. But in your year 1, you do not have any cash flow. So we need to adjust. Let us remove those years where we haven't received any cash flow or we have paid any cash flow. I'm going to take this example again, and we calculate the present value. We are going to assume that our cash flow is going to start from year 4 to year 10. That is what we have. So we have a cash flow starting from year 4 to year 10. We call that a delayed annuity. What is it that I'm going to do? I'm going to have, if I'm to adjust the annuity factor for the years that I haven't received. Final year, annuity factor, final year, annuity factor, final year. My final year is year 10. Alright, I'm going to calculate year 10 annuity is equal to 1 minus 1.12 to the power negative 10 divided by 0.12. Alright, this is my annuity factor for year 10 at 12%. But look now, I have to less annuity factor before annuity factor for a year before start of cash flows, annuity factor year before, year just before, right? Let's put year just before, year just before cash flows start. So my cash flows started in year 4. Before year 4, I have year 3. So I have year 4 there. If I go back, there is year 3. So I'm going to adjust using year 3. So from this, I have to remove annuity factor for year 3 so that I am only remained with the discount factors from year 4 to 10 only. So I'm going to adjust using that. So the adjustment is quite easy. I can just copy this one, this annuity for year 10, I paste it there. I just change number to the power 10 here. I'm going to put 3. Alright, so my adjusted annuity is this minus that. I have 3 point something there. That is what I'm going to make use of. So if I'm going to calculate the present value of a delayed annuity, let me just copy this table here, right? I'm still receiving 7,000, but the years are now year 4 to 10, and 7,000. My annuity factor is the one that is adjusted there. So this is going to be the present value. If I do not want to adjust my annuity factor using this method that I have explained here, I can still do the same using accumulation of discount factors, let me have year. So since I just want year 4 to 8, I can have my year 4, 5, 6, 7, 8 up to 10, right? 9, 10. So I can just add the discount factors from year 4 up to year 10. That is what I want. So automatically it is adjusted because I have excluded year 0 to 3. All right, discount factor here. My discount factor is 12% equals 1.12 to the power negative 4. And I drag to the end. So automatically, if I can highlight there for the purpose of comparisons, if I can highlight there and I add my discount factors from year 4 up to year 10, this is still what you get. So you can actually make use of the table where you can actually take annuity factor for the final year and then you remove the one where your cash flows are not lying. That is what we do in terms of the annuities. So we going to make use of this issue of annuities when we are going to be studying the next chapter on a lease or buy, specifically when we have the lease payments, because these are going to be the equal amounts. Instead of us discounting the lease amounts every year, we can just make use of the even cash flows. Thank you for attending.